Given the following insertions and deletions, select the correct red-black tree. We have 1, 2, 3, 5, 4, 6, 7, and 8, and we're going to delete 4 and 3. So first we're going to insert 1, and 1 is just going to become the black root node. Then we're going to insert 2, and 2 is going to become the red right child of 1. Now we're going to insert 3. 3 will initially be the right child of 2. Note that 1 has a null left child, and so we're going to say that it has a black uncle, a red parent, and a black grandparent. So in this case, we will rotate left. 2 will become the root. 1 will become the left child of 1. 1 will become the left child of 2. And then we're going to recolor 2 and 1 since they are the original parent and grandparent. So what we're going to see is we're going to rotate here. And then we're going to recolor the original grandparent, which was 1, and the original parent, which is 2. And now we have our balanced tree. Next, we're going to insert 5. 5 is going to become the right child of 3 and will be originally red. Here we have a scenario where both the uncle and parent are red. So therefore, we are going to recolor the uncle, the parent, and the grandparent. So 1 will be black, 3 will be black, and 2 will be red. The next step is eventually we're going to get to the top of the tree, and 2 is going to be red. 2 is the root node, so it will be recolored to black. Now we're going to insert 4. 4 is going to become the left child of 5. And it will be red. And now we have 2 things we need to bear in mind. The uncle is black, and we have 4 and 5 as a red child of a red node. 4 is less than 5, and it's going to be greater than the grandparent, so we have this zigzag scenario. So because of this, the first thing we're going to do is we're going to move 4 up, and then we're going to make 5 the right child of 4. And this will take us from case 1 to case 2. So now we have, again, the black uncle, and we have the child, which is 5, the new parent, which is 4, and the new grandparent, which is 3. So now we're going to rotate left, and 4 is going to become the new root. 3 will become the left child of 4. Like so, and then the original grandparent, which is 3, and the parent that is at the stage we were at, which is 4, will be recolored. And so now we have our balanced tree. 6 will be inserted, and 6 is going to become the red right child of 5. And now again, we have red uncle, red parent, black grandparent, so those are going to be recolored. And then we don't have any other scenarios that we're going to run into, so this tree is going to... Now we're going to insert 7. 7 is going to become the right child of 6. So in this scenario, we have a black uncle, so therefore we can rotate. 6 will become the root of the new subtree, 5 will become 6's left child, and then we're going to recolor the original grandparent, so 5 will become red, and the parent at this stage, which is 6, so 6 will become black. So first we're going to do the rotation, and then we're going to recolor 6 and 5. So we're still in good shape. We have a relaxed balanced tree. Now we're going to insert 8. And if you're preparing and working on scenarios for this exam, the one thing I would recommend is have at least one case produce what's going to happen here, which is going to be a large, multifaceted rotation to one side. So here what's going to happen is we're going to make 8 the right child of 7. Here, it appears as though we might not make any rotations. We have a red uncle and a red parent and a black grandparent, so we're going to change the color of 5 and 7 to black, and we're going to change the color of 6 to red. But here's the thing. Red-black trees are local. We want to go up and use recursion and local to provide this relaxed balance. So now we have a scenario where 6 is the child, 4 is a red parent, and then we have a black uncle and a black grandparent, which means we're going to rotate. So we have to keep track of 4 and 2 because these two are going to be recolored at the end of this step. We're also going to see that 3 is going to become 2's right child. So let's move and perform this rotation. So we're going to see that 4 is going to move up and 3 became 2's left child. The last step we need to do is we need to recolor 2 and 4. 2 was the original grandparent in this step and 4 was the original parent in this step. So therefore they get recolored. And so now we're at the end of the steps before deletion. So now what we're going to see is that 4 is our first deletion. The first step is that we're going to go to the left-hand side and get the largest value and replace it in that node. So now we're going to see that if I delete 4, 3 is going to be moved up. And so now we have an issue. We don't go through the same number of nodes in every step. So what's going to happen is we're going to change some colors. We're going to change the coloring of the deleted node, and then we're going to change 2 and 1. So now we have 2 nodes that are black to every single leaf node in the tree, to every null pointer in the tree. Now we're going to delete 3. So when we delete 3, what you're going to see is we are going to get this one moved up, and then we're going to pull this up, and then what's going to happen is we are going to recolor 1. And so this is going to be our final tree. So we have 2 and 1 on the left that are black, 5 and 7 are black, and 6 and 8 are red. And we see that D is our correct answer.